everybody. We appreciate you being here. Probably this is part of our community initiative here at the Charleston Digital Corridor, and we welcome you this morning, and we are very happy to have Jason Finney-Frock from Boomtown and Tom Wilson from Jack Russell Software, and they're going to explain what they do a little bit better than I ever could, so I'm going to let Jason take the lead this morning. So thanks, Jason.
Thanks, Matt. Good morning, everyone. So I'm from Boomtown. Jason Finney-Frock. It's me on Twitter. I was the third guy over at Boomtown. Whole system used to install on one machine, and it used to live on one server. So I know the monolithic architecture very well. We got started on ASP.NET 1.1. Made the huge leap to 2.0. We used a system called net tiers, which would basically look at your database schema and generate you this giant pile of code of data access and service layers and stuff. So I have helped build and live with a good-sized monolithic architecture for a number of years now, and seen the way that it grows and groans, and seen it kind of fan out across a couple different servers. So I feel like I know a little bit about what I'm talking about on this. What is a monolith, right? I don't know. Does anybody who here knew this already? Maybe I could just skip over it. It's a giant hunk of stone, like an obelisk or like these sculptures. It's used to be something that people used as a way to grow a statue up pretty quickly. I guess you could lay it down sideways and carve on it and then stand it up. And there you go. So I think it got applied to programs as if the program was this one chunk, this one entity. Any of us who've done like Java work, where you have like a single jar file to deploy, I guess that's a pretty good example of a monolith. So it's a little bit of a loosey-goosey term. I'm not sure technically it has a real concrete definition. These guys are considered monoliths. Here you're probably going to deploy a jar file. Here you have a lot of DLLs that you're going to deploy. But these guys, they're just folders full of files. I mean, it's one sort of system that's tied to each other. But that has huge implications. Like right now, we have a pretty good-sized WordPress install. It has huge implications on how you develop and how you deploy. So, not all bad. Let's talk about the good things about them. Most of them are pretty dang easy to install. Rails and WordPress especially are known for their being easy to get spooled up and easy to run. Debugging and profiling is always pretty damn easy, especially since some of them tend to have editors built around the entire tech stack. So the Eclipse guys know what I'm talking about. Visual Studio is like an operating system in and of itself that is built to deal with Microsoft code. So debugging and profiling that, pretty dang easy. Deploying, depending on the technology and what you're doing, it tends to be one hunk of code that goes to some folder on some server. For the longest time, we did nothing but FTP. We used a program called Beyond Compare, which is just a file folder comparison. I think we still do a lot of production deploys with Beyond Compare, because it'll look at, here's what's on my computer, here's what's on the server, here's what's different, and you can even push lines of files that way. We're heavily automating things like a lot of places are, but the old timer in me still misses the days when I could just Beyond Compare up onto the server and be done. I used to have phone calls with clients and be able to fix bugs as we were talking to them. I could just fire up Beyond Compare, edit the file on the server, and then sync my change back down to my computer and say, hit refresh, try it again, let's go. And that was because I didn't have this multi-headed beast of a many server kind of architecture. So this monolithic architecture was really nice to us for a while. Reasoning about it, depending on how you organize your code, when it comes to debugging, and especially if you're going to set breakpoints on something, if all your code more or less lives in the same place on a file system, it's pretty easy to step down through it and find out what's doing what, who's talking to what, and you can watch it go all the way down to the database and all the way back up the chain. So like I said, depending on how you have it architected, it can be pretty easy to reason about, and it's the devil we know. Some of these things that we're going to talk about today are new concepts. Well, this is something that's been around for a while, so we have a lot of knowledge built around having a large code base and how to deal with some of these concepts. So I think when we say a monolith is bad, well, a lot of times what we're talking about is good code versus bad code. And like I said, early on, Rails, WordPress, those are considered monoliths. I think they're pretty good monoliths. Hell, I guess you could build something in Sinatra, which is super minimalistic, and still consider that a monolith because it's one big hunk of code. But, you know, are you talking to a single database? Is that your choke point? When people say, oh, it's a monolith, it's bad, sometimes what they mean is our database is screaming and we can't fan it out very easily. Or our code is organized in some poor way. Model view controller is a way to help you organize your code and the ideas in there. Unit tests are something that can help you out quite a bit. If you're telling me I can't change this code because it's scary and I can't change it confidently, these are some of the things I would ask. Like, okay, how is your tests? How is it organized? Are you a single point of failure with your database? Do you have interfaces in there so that you're talking to interfaces instead of concrete classes? Because when you talk to an interface, you can start swapping them out at runtime. And then what language are you using? Or do you have to compile the whole thing, or is it just a folder full of files? If you have one bug in there, does it take the entire thing with it? PHP, I'll use as an example of that. WordPress is a giant folder full of files and a giant bunch of PHP. Depending on the severity of the error that you have in a PHP file, it'll just silently chug along. Throw something in the error log and you'll never know unless you actually look at the error log. So it doesn't, even if it's one ball of code, it still doesn't have to be a case where a bug will take the whole thing with it. It has to be a pretty serious bug. And some different languages have ways of not taking the whole thing with it. So I think this is what will lead you down to a bad monolith. And I think that the top one is probably the biggest one. You don't know the domain you're coding for. And the aesthetics is easy to say, extremely hard to define, but what's good, elegant, modular, pluggable code versus not? You know, everybody has their different ideas about that. I think a lot of times we'll code for fit rather than survivability. We'll take a piece of code and we'll keep hammering on it so that it fits all these use cases we have, as opposed to making a logging class just be a logging class and use it across projects, treating pieces almost like little open source pieces. Because once you do that, once you've hammered a piece of code into fitting like 2 or 3 little nooks and crannies that it has, now you can't change it anymore. It wasn't generic enough that you could use it elsewhere. Dependencies is something that I personally have felt sting pretty hard over the years. DLLs were, honestly, who's here has heard of DLL hell? I'm sure some of the Microsoft guys. I mean, DLLs, when they came out, were great, fantastic advances for handling dependencies, but we're very much have felt the sting of having so many dependencies in the system and one version of a DLL conflicting with another. So again, this may have nothing to do with ASP.NET. If I have 28 dependencies in my system, it may still be hard to change and hard to grow. And this kind of relates to this. If you have like a data access layer and some sort of module layer or a model layer, and you start to allow them to grow together and sort of fuse, you're automatically going to make it hard to change in the future. And that is not that's not anything that's inherently bad about having lots of code in the same folder together. That's just kind of bad programming. I've seen this one bite a couple times where you spin up a library of some sort of module, and then you just try and cover every possible use case that it'll ever do. Code changes, the business changes, everything changes. optimizing and gold plating stuff early on only makes it harder to change down the line. And then this one is another one that this has nothing to do with a big folder full of files, but like I said, we are still living with .NET 2.0 code, and code patterns have changed over time. Different types of data flows. We've got like some view models in there, some presenter classes. We have Windows workflow, which was a big idea for Microsoft at the time, floating around in there. If you live with a particular company's chunk of code for a while, especially like Microsoft or Sun, these patterns and these ways of writing code change over time. And at some point you'll have 5 different patterns like we have in the system, because the way Microsoft code was suggested and written in 0506 is different than the way it is now. The languages grow. Languages get more dynamic. I guess Java's probably gotten lambdas by now and some of the generic type things. Well, that completely changes the way you write your code. So we've got old kind of crusty delegate code and then stuff with lambdas all over the place. Again, so you kind of wind up with a mishmash of coding styles after a while. And again, that's just a matter of time and the fact that the language changes over time. So I think these are good examples of kind of what we're talking about. This was probably a perfectly good motorcycle, and that was probably a perfectly good bench, but they were allowed to fuse together. Now I can't change the motorcycle or the tree, or the bench or the tree, without doing damage. There's nothing inherently wrong with these two things, but they were allowed to fuse together. And I think that happens a lot. And that's kind of what I mean about coding for survivability, not for fit. It's a little hard to explain sometimes, but you probably all felt it, where you have a library that does one thing and then you start making it do another little thing to account for this one use case over here. And now I got a third use case, and I'm going to code a little bit, I'm going to add a little bit to it, and you kind of keep tacking on to it. Now it's serving 3 different things, and when it comes time to change it, you say, oh, we can't do it because it's got this other thing over here. And then what's even more fun is when you say, this thing depends on this other thing, which depends on this third thing. Now we're really in bad shape. Again, we're talking about architectures, and when we're saying this architecture is good, this architecture is bad, I look at this as monolith, this as microservices. Both serve their purposes, both have their benefits. This guy is something to behold. He'll probably, he's been around for hundreds of years, probably will be around for hundreds of years. Something built out of shipping containers, he has a different set of requirements, concerns.
Even the plants are in pots.
Yeah, exactly. So, like I said, these are architectures. They're not magic bullets. They have trade-offs, and all code is a trade-off, right? There are good parts and there are bad parts to them. I say minimize and work around the bad parts and exploit the good parts. And just be clear that complexity will live somewhere in your code. It may be in a chunk of code files. You may have decided to push it off to your database. You may have decided to push it to your networking architecture and how one machine talks to the other. When it comes to deployment, like I said, what kind of language are you deploying? Is it a matter of just throwing some files on a server and calling it a day, or is there a hefty compilation process in there somewhere? And finally, does it have to be either or? Can you start simple with a monolithic style of thing and then have it fan out from there? One shining example for us has been WordPress, which is, we don't touch the WordPress core at all. We develop plugins on top of WordPress. WordPress core changes, our plugins change along with it, and the two can move along nicely side by side. And then within the plugins, we have widgets and themes, which also can change independently of the main code bases. And as we want to spin up new features, we just start writing a plugin. And one plugin A can live right beside plugin B, and we can kill off plugin A when we decide that it's time. So, like I said, technically, I guess that's a monolithic architecture, but it's also nicely pluggable. I think the JavaScript world is probably going to arrive at something similar because JavaScript is as dynamic as it is. You have this ability to kind of patch things on and cover up some of the parts of the code you don't like. That's it for me. Thanks. I will turn it over to my esteemed colleague and the loyal opposition.
All right, so I'm Tom Wilson, lead technologist for Jack Russell Software, a Tabula Rasa healthcare division. It's our new company name. But I think we got the monolithic definition pretty well, so I won't cover that too much, but just think of it as an application that's built as a single unit is how I sort of think of a monolithic application. And then you can think of it as Jason said, an application pointing to a database, maybe some caching, maybe some servers, but still it's one deployable unit. So all of your deploys are pretty much the entire application at the same time. And microservices does do things a little bit differently. Inside the application, though, in a monolith, you do have components, and you do separate your code in components, so it's not just one big file with a whole bunch of code. You do separate them either by model, view, controller, or some other paradigm. And by being in process, that's very fast. So you get a lot of return by separating your code, but then communicating in between. So understanding the monolith will help me explain microservices. So imagine that you have an application, but instead of all of those components being in process, they actually exist outside your application. And you're using different mechanisms to communicate to those components, and they all work together, but they all can be deployed independently. And those interfaces could be HTTP web services, or they could be some sort of queuing enterprise bus, or a pub sub system. But basically you have your application and all of its processes or components are outside of the application. But the interesting thing that I think about microservices is it's also about team organization too. And there's a guy named Conway who came up with a law that any organization that designs a system defined broadly will produce a design whose structure is a copy of the organization's communication structure. And what that means is your architecture really mirrors your communication flow within your development team. And I believe that. I've seen it happen. And with most traditional development teams, you tend to organize around technical silos, right? So you have a team of designers, a team of front-end developers, back-end developers, DevOps, DBAs. And when a feature comes in, you have to take that project, if you will, and go and acquire the right resources to accomplish that project. And in a monolith architecture, you tend to, you get the designer, the front-end developers, the back-end developers, and you go through that process and you build that feature, all in the same monolith. Well, microservices sort of encourages this concept of grouping by your business domains, where you associate teams to accountability for certain business products, services, or platforms. And by breaking that team organization to focus on product ownership and service ownership, then you can decouple that monolith and have teams focus on features that are specific to isolated pieces, and they are loosely coupled, so they don't have to wait on someone else to deliver something. They can go ahead and push theirs up, and if the other team, once they get their connection, they push theirs and they connect. But then it also allows for teams to work independently and maintain backwards compatibility. So I can push a service of version 1 up, and product A, B, and C could be connecting to service 1 version 1, and then product D could be connected to service 1 version 2. And they can live together in harmony, and then when A, B, and C decide to upgrade, they just point to the new version, and then you kill version 1. And with that kind of flow, I think brings about this talk of microservices. So addressing the needs for complexity. These are some of the things that really led us to microservices. The need for multiple presentation layers, right? So we need something that works well on mobile, something that works well on the web. We need something that's more focused on a particular user's role workflow, and something that's same data, same services, but focused on another role's workflow. So we have a lot of cross-functional features. We have multiple persistence models, right? So if you have a very sophisticated back-end where you're using NoSQL and SQL, caching, and all kinds of persistence models, it becomes very difficult in a monolith to maintain those things. Multi-site replication. Again, microservices will help you architect the ability to have your systems being in multiple sites, and really can give you replication for free if you leverage event sourcing, for example. And event sourcing is where you pull all your writes, if you will, through one central logging system like a Kafka or like a RabbitMQ or a CouchDB, and then you replicate that, and all your persistence layers feed from that particular source. Another couple of things that we really liked about microservices is this idea of developers and the support of having multiple languages in your application. So I think with the monolithic stack, you're sort of imposing on your innovative team to work in one technology channel. With microservices, you can open that gate and allow the development teams to pick the right language or right tool for the right purpose. And then feature experimentation. Oftentimes, you don't necessarily know the right solution for a particular problem, and you may have 3 or 4 solutions in mind. With microservices, being able to run multiple versions of your services and multiple versions of your application, you can experiment and do A/B testing, ABC testing, things like that, without taking your full system down and having to deploy that. So the way that I sort of see our microservice platform, and I think one of the biggest commitments to microservices is embracing some of these new infrastructure as a service and platform as a service tooling that's come around in the last few years. We look at a platform as a service, and we use an internal cloud foundry, which allows us to rapidly spin up applications automatically, run multiple instances of those applications, and control them in a very secure, audible, DevOps-friendly way. And then we have this pub/sub log in the middle, which these apps don't really know where the databases, where the persistent engines live. All they do is they send an event over requesting for information to come to them. And then we have a platform as a service running services. And these services, they manage their own data persistence layers. So the services are in control of their own data persistence and manage those connections to that. And then they respond back on the pub sub back to the application. Yes?
What's pub sub blog?
Pub sub is short term for publish and subscribe. So let's say an app wants to execute a query on your SQL database. It'll publish an event saying, hey, I would like to get a list of widgets that start with the letter A. And then that publish event will be a service. The widget service would be subscribing to those events, right? So the event comes up, the widget service receives that event, and it goes and it queries the database, returns the data, and then it publishes an event back onto the queue saying, here's your query response. And the app is listening for that event, subscribe to looking for all the query responses that have this transaction ID. And then it comes and it gets the data and paints the data. So you're creating this, this communication channel abstraction between your data layers and your presentation layers. Does that make sense? So I think the real thing about microservices is that you have a lot of complexity in your application. Let's say you want to add metrics. Let's say you want to add blogging. Let's say you want to add a lot of workflows in your application. Microservices gives you the ability to push a lot of this complexity to your automation, to your infrastructure, so that, you know, in this paradigm, if you've built your application and the user comes in and says, you know what, I want to start capturing metrics on those widgets. How many times people respond to that widget? How many times, or how long does it take for our responses to come out? Well, now I can just plug in a service that subscribes to that, and it may not do anything, but it just listens to those events. And it starts sending that to a metrics database. And the nice thing is now I'm getting metrics, but I haven't had to impose into my applications and services that code. It can live outside of that code. And the same thing with features. So by splitting this up, oftentimes we get into problems with our monolith where users have this really great idea for this new feature, but it's for a, let's say it's for a pharmacist, but then we also have nurses and prescribers on our system. Well, it goes into our monolith, and we have to debate and go through several, several edge cases. I want to say 100, but it may not be quite 100, but several edge cases of trying to debate how this feature is going to affect all kinds of different workflows. And oftentimes, what you don't want to do is introduce a new feature and introduce a bunch of bugs. And you have unit tests and you have all these things, but at some point you just step on each other's toes, right? With a microservices platform, if you have a service that's just focused on widgets and they own widgets, when a new feature comes in, 9 times out of 10, it's only going to touch a few services and a few applications. So that debate and that analysis that has to happen is a lot less painful, and usually you have a lot better estimates on when you can get something out the door. So it is complex, and I think that's the big pill to swallow with microservices is, well, monolith is easy, right? You just run a command and you're running a monolith. And so when do I start to go to microservices? Do I go when it's too painful to run a monolith? Or do I start at the beginning? And that's a good question, and I think that's up for debate. What we tend to do is anything that we're doing from an integration standpoint, where we're working with multiple systems, we deploy microservices and have been quite successful at that. From a prototyping standpoint, where you don't know if this is going to stick or not, I think a monolith really serves that purpose very well. To build all of this infrastructure out to prototype something would be a lot of work, and it may not fly. But microservices, I think, also, again, going back to Conway's law, makes you think of things in terms of products, not projects, right? So, we've got services that several of our platforms use, we want those to be thought of as products. And the best example I have is Amazon Web Services. So if you go and look at Amazon Web Services, things that you would have probably thought a few years ago that would be a project, they've turned into products, right? So a perfect example is S3. S3 stores files on a federated disk system, right? And it gives you access to your files across the data center, or multiple data centers. They've turned the art of storing a file into a file system into a product and a service that people pay for, right? And I think that's sort of this idea of services. The other one is smart endpoint and dumb pipes. So a lot of times people read microservices and they think SOA, service-oriented architecture. And I think the key difference between microservices and service-oriented architecture is the fact that, in my mind, or my opinion, service-oriented architecture had smart pipes, right? We're going to send types through the pipe, and each side needs to know those contracts. And if I send a contract through and this side doesn't recognize one piece of that contract, it breaks, right? So it becomes very brittle. Whereas microservices is saying, let's send data through as JSON or as XML, and then make the endpoint smart. So if we make our endpoints look for what they need, but if extra stuff's added, we don't care. We just use the stuff that's there. And what that allows for is these endpoints to be backwards compatible as we add new features. They can still run and not go down. Decentralized governance. And this goes into the idea of allowing the development teams to use different technologies for different platforms. So microservices, you can have a service that's talking to a CouchDB that's running Go, and then another service that's talking to SQL that's running Ruby. And they can all coexist in the same app and not get into each other's way. So I think being able to do that will allow for us to get the right tools in and the best developers, and continue to keep our application sustainable. Decentralized data management. Microservices gives you the flexibility to use SQL starting out and then play around with this idea of, well, maybe a CouchDB, maybe a MongoDB will work better for this particular case. We can actually run both at the same time, and we can use metrics to measure which one's performing better and how that's happening. And then, switch without the users ever feeling any pain. You may be familiar with the term of dark reads and dark writes, right? So a lot of times these big companies like Facebook and Twitter and all these guys, they are all constantly redefining their back end to be more performant, but they want to do that. They can't take the system down, right? So they do dark reads and dark writes, and they may be running a shadow back end, and you may be using the initial one, and then once they're happy with the performance, they cut you to the new one, right? Microservices gives you that kind of flexibility. Infrastructure automation is a huge requirement. You can't do this without automated infrastructure. You've got to have that automation in a more continuous delivery. So each individual piece has to be automated. It has to run through its own test pipeline, its own deployment pipeline. And you design for failure, right? So you build these things, and what's really interesting by leveraging a Kafka or a PubSub commit log is every single commit is recorded. So if your database gets corrupted, you can literally bring up a new service and go to the commit ID of 0 and start repopulating a new database through that commit log. That's how relational databases work in the inside, right? That's how they recover from corruption. By taking that to your application level, again, you make your data very resilient. Evolutionary design. So I think this is one that's more important for me. So I've been developing systems for 20 years now, and you know, there's some wonderful people that are still working on a system I built in Delphi, right? And they're building that in Delphi, and they can't get out of Delphi because they're stuck in this monolith. With microservices, they could evolve into different pieces and not be stuck with that, but you're still serving the same product to your customers over time. And I think a lot of times when we're building products and software, we don't think about this enough. We don't think about how is this software going to last for 10 years? How's it going to last for 20 years? How's it going to last for 40 years? You know, I want to write code that's going to last for 100 years. I'd like to see Tom Wilson on GitHub somewhere in 3000 or something. Be kind of cool. But, you know, if you look at how our software churn is we're just in this rut where every 4 years a new technology comes out and we rewrite everything. Every 4 years another new technology comes out, we rewrite everything. And we should be, you know, trying to build robust systems so that we don't have to spend so much time rewriting, and we can focus on innovating and evolving. And I think microservices leads to that. You know, Rails was a wonderful innovation, but now with the new web browsers and the new tools available, that pattern becomes less and less a good fit for certain problem domains. So what do? You have to rewrite. I think the interesting thing is with microservices, rewrite becomes a friendly word, right? So if you have a service, a widget library, and it's 2 pages long, and you go up and say, well, I want to add this feature, well, I have to rewrite it. Well, that's 2 days to rewrite, not 2 years. So it actually becomes part of your culture, is this idea of rewriting to get better. So that's pretty much an overview. You can dig deeper into microservices through Martin Fowler's article. He really goes into these points. And me and Jason and Andre and some other folks are working on a concept called Palmetto Flow that we're trying to define these microservice architectures, and it's an open source thing, and I encourage you guys to check it out. And if you want to get involved, we're just trying to really put this concept into something that will provide practical implementation routines, and not just for specific languages or tools, but just so, again, I think the last benefit is if you have this type of architecture, you can bring in new developers and they don't have to know the whole entire thing. So they can come in and get started and focus on key pieces and immediately become productive without having to encompass this whole system. And it's funny, Jason said that he could run his whole environment on his development box. With microservices, we never run the whole environment on our box. We have a development environment in the cloud running as a platform as a service, and there's no way we could run it all on a single box. So we go ahead and embrace that fact, and I think it makes it a little bit nicer as an experience, because you don't come in and spend the first day loading all this stuff on your system to try to get going. So that's all I have. Take some questions.
So what are the downsides? Like, you know, I can imagine if you have some data in a SQL server and some in a CouchDB, you may have operations that need information from both in a way that require you to query over here, then do something over here, then go back. Does it slow things down? You know,
Right, so in process will always be faster than out of process. But again, the technology and the architectures now with the caching has come such a long way. You can overcome a lot of that. And then I think you learn certain queue strategies, right? So there's, how many people have heard of zero MQ? A few? Well, they do a great job of publishing these queue strategies where you can do a pub sub, or you can do a fan out and fan back in, and you through your events and your services, you take advantage of those strategies. But the nice thing is that your application and services really don't know much about that. All they know is, I just need to do one single thing and do it really well.
So you guys stand up an entire stack for each developer, so they have isolated environment?
We have a development stack. And so we have a whole pass that's dedicated to all development services. And they can spin up their app. So I may be wanting to work on a widget service, and Andrew may be wanting to work on a widget service. He can spin up widget service 1, I can spin up widget service 2, and work on those. So they have access to a platform as a service, and they can spin up their stack and spin it down how they want.
So as an example, if my service, I was on the server side interacting with some data on the back end, does it also spin up a standalone copy of that back end data source so that we're not stepping on each other? That's
Yeah.
one of the problem we ran into.
Yeah, so what we're doing, we have that same problem, and we're working on working with Docker and using Docker containers to do that. And right now it's manual, but we are working on automating that, so I can say, spin up a CouchDB for me. And then someone else could spin up a CouchDB for them, and they can spin it down and spin it up. But right now, we're managing that. And it's very easy using the Docker API. You just pull down the image and you spin up something, but still.
Well, that's actually where we ended up, is we circled around to basically putting all of our stuff in Vagrant with Ansible to fully provision the box, stand it up, so that way, it's repeatable. And everything stands up locally and talks to each other. But I guess if you get into the hundreds of services, like that strategy's gonna break down too.
Yeah.
It works for a while.
Yeah, Uber actually forces all their developers to work in Amazon AWS, not in their development box. It's kind of interesting.
Quick question.
Yes,
Do you guys do CQRS?
sorry,
Command query responsibility segregation?
I couldn't understand it.
The CQRS,
QRS.
the command query responsibility segregation?
We don't. Right now, we do events. So we generate events, and those events don't, basically all they require is a unique ID and a timestamp, and then any metadata. And then our central commit log manages who can subscribe and who can publish, right? And it has all the access control lists from there.
So is having the queue in the middle with the pub/sub model, the primary advantage, basically this audit logs, to me it seems, I was just thinking about what are the advantages to basically having your clients go straight over REST? Because really REST is already a layer of abstraction at the service level, so it's like adding another layer of abstraction, which means different models and different understanding on both sides. So what are the key advantages to doing the pub/sub?
Well, the key advantage is multi-site replication and recoverability, right? So if you're logging everything, then you can replicate just that commit log, and then all of your data sources on either side of the data center are just reading from that commit log. So they don't have to have any kind of back-end replication, right? And then the other side is dealing with WebSockets or RESTful architecture. Actually, the API RESTful endpoints are actually in front of the commit log. So think of if you do a post to a widget, that post to a widget goes to an app, which then publishes to the commit log. Data and it comes back and responds back.
On the reads, I'm sorry I didn't qualify that.
Sure.
I actually wrote it down as the writes. I totally get that, but the reads. What's the advantage on the reads?
Really, from our point of view, and people do it either way. If you look at Flux. The Flux architecture, and then there's an enterprise Flux type of thing where you go straight to the store for the reads. We want the reads in just from the metric side so that we can do response times and metrics without embedding that code. So we want the reads to go through that channel as well. And then the other proponent that we look at is having to maintain a registry, right? For each one of our apps, we only want it to know where that log is and not have to keep up where the IP and port address of every data source is it wants to get to.
So, no, I'm sorry. Go ahead. No.
Go ahead. He already asked a question.
Yeah, yeah. No, because you were talking about a commit log, and so is this commit log collection of XML that these data sources are pulling off a queue and persisting, or?
Yeah, it's a append only document database, right? So right now we're a lot of big organizations are using Kafka and Samza, Apache. And Kafka, basically you send a transaction to it and it just appends only, and it can be clustered, it can be replicated, it can be done. We're using CouchDB, some people are using RabbitMQ, but the point is the same, is they need to be very embracive of heavy writes, and they're not built to be necessarily read friendly, right? You can read from them, but your main intent is to be super fast at writes and very good at replication and very good at pub/sub.
Yeah. So, well, in this case, it seems like, yeah, if you have you're integrating these applications, and you don't have one main flagship application or a family of applications that share one mission that's doing a primary thing, then which reads are typically, normally you're going to be refactoring because you want to get response, you want to get your customers this data back as quick as possible. When you're publishing several services with different versions and you want to refactor for performance, you can't have an append model such that you can't refactor it later when you find other ways to optimize your data persistence, your data retrieval, and stuff like that. So it seems like, for different applications, this microservices, which, you're talking about registries, you're talking about service oriented architecture to me, but at the same side, when you have one application, one company doing one suite of things that may offer services to integrate with other partners, one monolith seems like that's where you want to go to pull out the performance that you need. So
and I don't think I'm standing up here saying here's a silver bullet, this is how everything should be. I'm standing up here saying that this is a different way to look at things that may or may not solve your problems better, right? So we have problems where we want to use different languages, we want to use different tools, and to force all of our innovations into a Rails stack is just not pragmatic anymore, right? Because we need to leverage graph databases, we need to leverage document databases, we need to have the flexibility to run multi-data center, right? And this type of architecture allows us to really manage something reliable versus releasing, and we have two products. We have a monolith, and our monolith we release every 2 weeks, and it's like launching a space shuttle, the amount of servers and the amount of work that has to go in to do that. It just flows. When a new feature comes up, it goes out, and if nobody's ready to support it, it doesn't matter, nothing breaks. They keep using the old version, right? So it just, I think you need to look at, just like with anything, you need to look at your problem domain and find the right solution that meets that.
Can I actually answer that too? 'Cause
Sure.
I work at Blackbot, so I work at one of those companies that has a family of things that we have some monoliths, and we've been doing microservices for a couple years. And one of the things that we found with the monolith is, while it's easy with one code base to go in and tune something, that we actually start to encounter a lot of problems at really, really high scale. And in some cases, everything's so tightly coupled, you run into the same kind of problem that you do with that pub/sub, where if you have a monolith, generally at the end of the day, you're going to be talking to one or more data stores, but it's still, you run into the same refactoring problem. The microservices, you don't actually have to have a pub/sub. We're doing microservices in a lot of places, and there is no pub/sub. It's just like you're saying, with the REST calls back and forth. And so the way that we're dealing with things like trying to improve response time is each service is responsible, right, for its response time. And we have different data stores for different types of things. We have read-optimized data stores, we have SQL, we have NoSQL. So I think you know, it really depends on the problem. I wouldn't recommend to always do microservices, having even lived in both worlds for a while now. But the bigger thing that I want to add too, to what's the downside of microservices, is I'm not sure if I can put enough emphasis on the organizational change that needs to occur to embrace microservices. Because as you scale up, with a monolith, it's pretty easy to have lots of people writing in the same code, and everyone's working on one product, and there's one person saying what needs to get done. When you switch to microservices, you have all of these different services, and each team is responsible for their own. And if I need something from your service, I have to work with you, and I have to get you to make that change so that I can take advantage of it. In monolith world, I would just go make that change, and it would have been really easy. And so, not only that, you have to stop thinking in terms of end user features always, and you think about those, but you also have to think about what is the service's purpose, you know, and kind of a little bit of a CQRS. It's like, what does this contact service do? It's not, I need to be able to support someone adding and editing, you know, names and addresses. You have to think about it at a service oriented perspective, which is a really difficult thing to do, especially if anyone has like product owners who own products. They don't think that way. So organizationally, you end up encountering a lot of challenges.
Yeah. And like Conway's law too, we're actually right smack in the middle of this. Your architecture will inform the way your people are organized and vice versa. And you can't do one and not the other. If you're going to go a services route, your people structure will change along the way, and we're right in the middle of that. And honestly, it hasn't been too difficult, but there's no getting around that. Both are going to change simultaneously.
So it's kind of interesting that doesn't say the organization's structure, it says the organization's communication structure. I mean, I guess a lot of that's the same because it has to do with who's reporting to who.
One quick question.
This is
Sure.
a thought.
If you were to start from scratch, how does microservices influence your design, where you choose to persist your data, whether it's SQL, no SQL? Is there a change from, let's say, a monolith that would touch 3 data stores?
Well, I think you can evolve a monolithic architecture into a microservice architecture, right? You have to,
From scratch. What,
if you're starting
how
from
would you do it
scratch,
differently?
how I start from scratch or recommend is, you prototype and you focus on what you know and don't focus on what you don't know. So if you're building an accounting platform, right, that's very well defined in the marketplace, then maybe a relational database is there because all your data structures are well defined. But if your boss comes and says, create this new thing and says, I don't know what it is, but this is the vision and you've got to figure it out, which happens a lot in our world. I'll take and do a prototype with no back end and everything in JavaScript on the front end, and keep everything using PouchDB as a data store, or you could use Web SQL or whatever, and have everything as just a static front end single page application. Let them change it a million times over until we iterate through what it is they want as a prototype. Then from that, really start to make your architectural decisions. So at least get that, their hands on it feeling, because I've run into so many times that we've over-architected something, choose too many robust things and all that gets thrown away, just like Jason was saying, or then other times we're too light, right? And we end up shipping something that's brittle because it doesn't have the robust complexity that needs.
What would be over-architecting example? Vertical partitioning or?
Well, I guess in our world is, and I'll just use a simple one, CRM. So say, hey, go build a CRM for nurses, right? And we go and look at the textbook CRM and we build everything based on that. But what they're really talking about is a patient relational system, not a customer relational system, right? But in their terms, they told us, this is what they want. So next thing we know is we end up with a data model that doesn't fit their workflow. That's the best I can come up with on the fly. But
I can add another one.
okay.
So microservices, you kind of have to embrace this notion of design, develop, and deploy, and those things being three separate things that can occur. You can design the system in one way and think about things like separating reads from writes and thinking about, and you can develop it towards those ideals, but you don't actually have to go all the way. And what the microservices let you do is come in later, and if you want to change from, okay, instead of deploying these web services all on one machine, we're going to deploy them on 10, but you designed it and you developed it to support that. You just didn't choose to deploy it that way. And so what you can end up doing is you want to make decisions faster. You want to fail fast. And over-architecting is, on day one, you go, okay, well, let's think about our use case 4 years from now. We need to make sure, we have to pick the right database to make sure that when we nail that customer 4 years from now with 1 billion records, that this is going to scale. Because to undo that in year 2 is really difficult in a monolith. With microservice, you're like, look, we have our cases for today, we're going to start moving, and we'll figure out that problem later, because dealing with failure isn't only about a component going down. Dealing with failure is also dealing with bad decisions.
Right.
So it lets you do both of those things.
Yeah, over-architecting would be like you build the Ravenel Bridge to cross a creek, saying maybe it's going to flood someday. We're going to actually need all this extra bridge capacity. Well, so let's go ahead and spend $20 million to do that. So it would be starting from scratch when you got 100 users and you've got some sort of like 5 replicated DB kind of thing, because you're like, well, someday it's going to be 1 million users and stuff. And you sometimes will read horror stories about Instagram, Twitter, some of these guys who hit scaling walls and stuff, but I don't think any amount of foresight would have helped them. They all have to basically periodically refresh the system in some way and do exactly like he was saying, like I've seen some of them do, like you can't have it all stuffed in a relational database and then say Britney Spears posts a tweet and 1 billion people want to read that. Like there's no way that you can do that in a SQL join. You have to have a data store that's optimized for reads and a data store that's optimized for writes. You're going to get forced to do that anyways. But at the same time, you don't even know what that's going to be. It's too far in advance.
I actually think there's also another piece with if you think about the monolithic, a lot of things that we're saying are advantages of microservices, you can get in a monolithic service, but people being their nature, you tend to take the easier path. And so you have something to do and you're on a time constraint, so you end up in a monolithic application, oftentimes breaking through the architecture and doing something that's simpler. And even the most militant architect can't stop everything. When you put up a set of microservices, you're not just putting up sort of a mode, you're putting a wall. So that says this is the way it will be designed. If you need this, you have to now go talk to these guys or go do this or go. You can't just poke over. You can't just do the easy way anymore. And that's, I think, in my mind, that's probably the biggest advantage of microservices. Because if you read about what the Amazon guys do, I believe they actually design, or the Netflix guys, they design every microservice that other teams aren't part of their company. Like you have to basically come to us like you don't know who we are. And our service will respond that way, and we'll deal with failures. We'll deal with even an internal service. They say, well, we will deal with a denial of service internally. If you are hammering us for some reason, we have to deal with that. So by doing it that way, you end up building this better architecture out the gate, and it doesn't break down over time. Because I think everyone's seen the monolith that started great. Someone had a big vision, 2 people, it was awesome. Suddenly you have 10, 20, 30, 50 people working on this application, and it starts to crumble. Because all these little bad decisions, or not necessarily bad, you just don't know. The junior guy comes in, he does a little bit of work, thinking he's doing the right thing, but he's not, or she's not. And then over time, that adds up. Microservice will protect you from that. Makes it a lot easier over time.
How does it affect you in terms of source control and people sort of stepping on each other's toes? Because to his point, it might be more difficult to get up to set up an environment to work in, because you might have to have some services set up, just so that you can test your service. But on the other hand, you're not having to rebase every day, because there might only be 2 people working on a service versus 8, and you're not sort of stepping on each other's terms in terms of source control. It's more modular.
Yeah, so we did standalone web services for a while for microservices, and had a little bit of trouble of people knowing what service to pull up. Even we're all on GitHub, but we've got 1 million repositories and communicating that, putting a registry for that. So that's why we're moving to this event log to make that more straightforward. So if you need to get information from a service, even in your development platform, you post an event, and that event will respond, and you can bring up the services who can listen to that and sort of use a platform as a service to bring that up. So you're not trying to put all these services on your box, and most of your unit testing is focused around your code, not everybody else's code. So you're controlling the inputs and outputs, and then our integration testing happens through Jenkins on a CI. So you write your end-to-end integration testing on a staging or a QA platform that tests all the components connecting.
Typically, you have to basically, this is one thing we encourage, it's a lot of overhead with mocking. You basically publish API as a contract just like an interface is in regular code, so that's your published contract, so you code to that. So we basically mock out REST responses and stuff to isolate, to allow for, I guess, the equivalent of unit testing, or really integration testing.
And a lot of people like Facebook are typing out all of their models and moving to flow type, which enforces every single model, which is a little bit more contract heavy. We haven't gotten there yet, but that's another way to do that. And basically every developer downloads all the types, and they can download them anytime it's changed, all the types come down.
How, did you run into any problems with basically aggregation of data that's split over multiple systems? I'll give you just a simple example of something we did that made life a little difficult. In one system we have our user profile, and in another system which handles more security related stuff, we have email address and say login count or something like that. And sometimes when you want to pull those together, basically you can't really do a join like you used to do and grab the data, so you've got to dynamically go over and get it. I mean, do you have any strategies for
just using the 0MQ strategies, and what we do is we have a transaction ID on each one of the events that we publish, and then we have a system ID, almost like a session ID. So we use that to track multiple fan outs and fan ins.
So as an example, if I pull a list of my users in some management panel, and they're by default 50 on the page. Does that mean I hit my DB and now I get user 1, user 2, and I make 50 independent requests and then merge? Now, I know the answer is no, but how do you actually? Do you make one mass request for give me this data for all 50 and then map it back together in your code right before you render it?
Yeah. So we would make an event request to say, give me the top 50 users, right? And then that would go into the user service, and if that service needed the last login time, right? When it makes its call, it will do a fan out to find all of those bits. But most likely there's some denormalization going on and some caching going on to make that more efficient. And you can play with that within your infrastructure and not inside your service.
It actually makes aggregation a whole lot easier too. That was one of the bridges we crossed a while ago, and it was our first big use of a distributed kind of messaging system. Was when things happen, I need to aggregate some data and plop it on a SQL table somewhere. It doesn't have to happen immediately. It certainly doesn't have to be a transactional type of thing. Just next 5 seconds, whatever. And that's a pretty nice little model for doing stuff like that. When you're talking data access, a lot of times there are I don't really care when this happens. The next 30 seconds is cool. Please make sure it happens, but other than that, we're good to go. And having your database buffered by a queuing system of some sort helps out a good deal for that too. And it also will smooth out the action for the database too. You'll see a database get a lot less spiky and smooth out a good bit in terms of its access.
Great, thank you.
Thanks.
Appreciate it. And if you have further questions, Tom and Jason will be around to address those. Thank you so much for being here. There's more coffee, so get fueled up for the day, and you're more than welcome to stick around for a little while and talk about the services here. So thank you.
Thank you.